Hello, my name is Gaute Tangen, and I am the Global Product Manager for Gentian Cystatin C. And I am proud to kick off this webinar series. And today I will tell you why you should choose the Gentian Cystatin C Immunoassay when selecting the Cystatin C assay to use in your lab. The agenda is a short description of what PETIA turbidimetry is. I will also tell you what Cystatin C is used for, the accuracy of our tests and the documentation behind this claim, and also the advantages of using avian antibodies. And once we are through, I hope that you will remember that the Gentian immunoassay has less interference, that it's platform independent, it is accurate, and is standardized against the ERM IFC-C standard material. PETIA turbidimetry. PETIA stands for Particle Enhanced Turbidimetric Immunoassay. This is a fully automated system, meaning that it's very little hands-on time for the lab technician. It is very rapid. The time it takes from putting the sample on the machine until it's analyzed is 10 minutes. And one of the advantages of this system is that it can run several samples together at the same time. So you get many thousands of samples analyzed every day. In this machine, we provide the immunoparticles. These are small beads that are coated with antibodies, represented by this Y. And in this case, you have a blood sample that contains several antigens. And the Cystatin C antigen is represented by this blue diamond. And the antibodies are designed so that they only attach themselves to the Cystatin C antigens. Once these are mixed inside the machine, the antibodies will attach itself to the antigens, and many can attach itself to the same antigen and then make these big complexes. This happens inside a cuvette inside the machine. And there's also a light source that, after passing through a light lens, selects light of only one particular wavelength. And then the amount of light that gets through is detected at the other end. And the more complexes you have formed here, the less light gets through, and the more Cystatin C you have, the more complexes you'll get. What is Cystatin C used for? Cystatin C is a way to estimate the GFR, and this is used to diagnose and to have therapeutic control of renal function. GFR stands for Glomerular Filtration Rate, and it is also used for, in addition to diagnosing and managing kidney disorders, to adjust drug dosages. This is because many pharmaceuticals are metabolized through the kidney, so if your kidneys are not functioning well enough, if you get too high a dose, the drug will accumulate in your body, and this is of course very bad and thus generates a need for the clinician to know your kidney function. And to determine the GFR, there are two main methods. One is to measure it, and this is done by injecting the patient with a specific substance, for example, inulin or iohexol. And then after injecting it, they are collecting the urine, and after a specific amount of time, they analyze the urine to see how much of the substance has passed through the kidneys. Now, this is obviously a labor-intensive method and thus costly, and also contains an element of risk for the patients. An easier method to determine the GFR is to estimate it by measuring a biomarker and then calculating the GFR by the use of an equation. And the two most common biomarkers are creatinine, and then the other option is Cystatin C.
Now,
how well does the Gentian Cystatin C assay compare to measuring it directly? In 2007, Flodin published a paper comparing the measured GFR by iohexol to creatinine and also to cystatin C. On the y-axis in these two graphs, you have the concentration of iohexol, and on the x-axis, you have the concentration of creatinine on this left graph and cystatin C in the right. If there was a perfect correlation between the measured iohexol clearance and the creatinine, all the blue dots would be on the black line, and R squared would be equal to 1. And you can see here that the Gentian Cystatin C correlates very well to the iohexol clearance, and that the R squared is very close to 1 at 0.9567. So how does the Gentian Cystatin C compare to other cystatin C assays available on the market? In 2014, the American Pathologists carried out a CYST survey, and this was published in 2015 by Eckfeldt et al. They sent out 4 samples, A, B, and C, and D, with various cystatin C concentrations, and that concentration you can see on the x-axis. And then you can see the different suppliers listed here. We will concentrate on the Gentian Cystatin C results. Sample A and B did not have an assigned value, but you can see that the Gentian Cystatin C measures just like the average of the other methods, bang in the middle here. These small dots represent the different samples, and the ideal is to have as little spread in these as possible. And you can see here that Gentian Cystatin C has very little spread, indicating that the Gentian Cystatin C method is precise. Looking here at sample C and D, they have an assigned value, which is indicated by this dotted line here. And you can see that the Gentian Cystatin C measures very, very close to this dotted line here in this sample, and bang on the line here in sample D. So based on these two studies, we can say that the Gentian Cystatin C assay is both accurate and precise. Now, we are very proud at Gentian to use avian antibodies, and we try to use avian antibodies in all our assays if possible. And this is because avian antibodies have less interference compared to mammalian-based immunoassays. And in the blood, you can have other factors that can cause interference, and you can have antigens in the form of rheumatoid factor, anti-idiotopic antibodies, and FC receptors. And as you can see, these are fairly common in healthy individuals. Larsson et al. Studied this in 1988, and he looked at 19 samples from RF positive patients, and in all 19 samples, when using mammalian antibody, there was interference. And in the control group of RF negative samples, there was no interference. And looking at avian antibodies, there was no interference in whether the patient was RF positive or not. So less interference with the avian antibody. We are very committed to quality at Gentian, and therefore we test interference against several components, like for example, common drugs that patients take. We also test it against the anticoagulants in the test tubes and against common components in the blood. In this case, triglycerides, lipids, bilirubin, and hemoglobin. The concentration tested, you can see in the right columns of these tables, and our assay passed the interference test at all these concentrations. And last but not least, we believe that using avian antibodies improves animal welfare, because when you are making antibodies, what you need to do is first vaccinate the animal that you are going to get the antibodies from. So vaccinate the animal, and then after a time, the animal will have produced antibodies against the vaccine. And if you have a mammal, the best way to get the antibody out of the animal is to draw it from the blood. When it comes to avians, we use chickens. We vaccinate the hen, and when the chicken produces antibodies, these antibodies are found in the end yolk of the eggs that the chicken lays. So what we do is just collect the eggs, and we believe that it's much better to collect eggs than to bleed animals. So we have the improved animal welfare. In short, to sum up this short presentation, the advantages of using the Gentian Cystatin C assay is that you will have an accurate assay. It's an independent assay, so it's compatible with all major instrument platforms. You'll see less interference, and you know that it's standardized against the ERM material from IFCC. The Gentian Cystatin C assay was one of the assays used when they were standardizing the measurements of cystatin C for the industry. Thank you very much for your attention, and if you have any questions regarding Gentian Cystatin C or any of our other products, please feel free to contact us at marketing@gentian.com.